All right, so we are on unit 7. You guys ready? There's not a lot of strategies specifically necessarily for unit 7, just because this is another one of those units that's geometry, so you have to actually know what you're doing. But there are a couple of the inscribed angle questions that I did want to like go over, because there's a certain type, there's a certain way these questions work. So I want to do I think 130 and 132. I think if we do those, then you'll have some good examples or some good sample versions of these problems that can help you in case it happens. They didn't happen that way in our unit, but they happened that way in this packet multiple times, and it's possible that they'll happen this way on the EOC. And so we want to just practice them. Okay. So it says we have a triangle ABCD that's inscribed in a circle. So when it's inscribed, it just means that the vertices of the triangle are actually touching the circle. It says AC is a diameter of the circle, which means that AC has to go through the center. If it's a true diameter, it has to go through the center and touch the center of the circle, and then also touch the edges. So AB is 12. Let's go ahead and label that. AB is 12. BC is 28. All right, and then AC is a diameter. Okay. So what can we figure out based on this picture? What can we do for part A? We can use the Pythagorean theorem. How do you know? How do you know it's a right angle? And what is a right angle? B is a right angle because, but how do you know that B is a right angle? Because, okay, so Lucas, how can you tell? So B, so this is the middle of the circle and B is off of the middle of the circle. There's a very specific reason we can say that it's 90. It was something that we learned. Trying to remember, it has to do with arcs and angles. So if we started with the angle of B, and we drew, so that's the angle of B, and we drew the arc that went with it. That's not what you said. That's what you wanted to, that's what maybe your head was saying, but that is not what came out of your mouth. Okay. So so if that is the angle and this is the arc, how much of the circle is that? 180. So what is the angle measurement? 90. So now we can conclude that's a 90-degree angle. Okay. That's exactly what, that is not what you said. That might be what your brain was thinking. That might be what your brain was thinking. Okay, so now we've proved it. Now we've proved it. That's a 90-degree angle because of, and the reason we knew that is because AC was a diameter. It was important that AC was a diameter because that means it cuts the circle in half. So we got half the circle, we got a 90-degree angle. So if we want to find the measure of angle A now, how can we do that? We've got a right triangle. So how do we know how to work with right triangles? Not sin though. I was correcting you. There we go, sine. So sine, cosine, or tangent. What are the two sides that we have in relationship to angle A? Opposite and adjacent. So what are we going to use? Tangent. Okay, so here's our angle. So we're going to do tangent of angle A. So this is actually unit 8 coming into unit 7. Uh-huh. We got some sassiness. It would have been nice to know this, Ms. Rice. I never gave you a question like this in unit 7 because you wouldn't have been able to answer it. So you never had one of these. But now that we've had unit 8, we can go back and we can actually answer questions like this, which is why it's actually on the review. So how do we get A alone? Tan -1. Okay, so tan inverse. Okay, and before we hit a sine, cosine, or tangent button on our calculator, what do we have to think about? Yeah, should it be in degrees or radians? And based on this type of question, we're going to be in degrees because we said 180 degrees, 90 degrees, we're going to be in degrees. So my calculator's in degrees. So I'm going to do tan inverse 28/12. You guys, this whole time I've been recording, I've been sharing the Desmos screen, not this screen. I've been sharing the wrong screen. I've been recording. Sorry, James. Sorry. I'm not recording people. I'm recording math. All right. Tan inverse 28 divided by 12 is, and it says to round to the nearest tenth. So what are we going to put? 66.8. So in here we got 66.8 degrees. It is complicated. Yeah, this is not a cheater method. This is straight up we're doing the math. The geometry ones are not usually, we're cheating on it. No shortcuts here. Joseph, are you texting this answer to your mom so she knows? She is really thankful. Are you guys texting at the same table? That is awfully flirtatious. Is there something going on that we should know about? You're dating and you got a text at the same table? Well, we all know now. So if you got, in case you got, we found in this episode of Bobcat News Wild, I don't know what it's called, Bobcat Daily News, Bobcat Friday announcements. Joseph and Annika are dating and they text during class because they love each other so much they can't stay away. They are playing footsie right now. I can see it just past a backpack. Madison is the head of the tricycle. She's the third wheel. That's what I meant, third wheel. Kel, don't make it weird. Kel, don't make it weird. That's exactly what's happening. She's right. She's right in the middle. She's right. They're not even sitting next to each other. They're sitting across from each other. Madison's the middleman right here. Whew, poor Madison. Poor Madison is right. All right. Let's move on. Let's move on. Okay. Does everyone feel like they've got the 411? We feel better now that we all know. I suspected there was an awful lot of flirting going on. Now I know why. Now I know why. James, why didn't you tell me, man? Rude. All right. We do not talk about which students are in relationships. no.
Teacher gossip?
No. No. I don't know what you guys, if you get, no, we don't talk, no.
So the teachers are out of the loop.
No. When the teachers get together, we have better things to talk about. Yes, we do. We don't go like, hey, what have you heard about student relationships? Who's dating who? That's the last thing. We're adults. We are grown-up people.
So you talk about who you guys are.
Yes.
And you so is there teacher gossip?
We are human beings.
So that's crazy.
Of course there's teacher gossip. Come on.
That's crazy.
So in like the break,
Can you share with us?
Yeah, are you feeling a cold absence now? No, Annika moved her foot. Her foot was on top.
That's a warning sign. It's a warning sign.
Yes.
Wait. Is it a red flag or a yellow flag?
That's yellow. There's no yellow flag. It's just a What is going?
I mean, the liking each other stage is important.
I like how yeah.
All right.
You can't break that power.
Yes, you can. Definitely can.
Is that why Joseph moved back? He was just trying to get on his way to that table?
He was all boy.
Wow.
Joseph was 20 steps ahead.
Man. This is like, did Court just ask what's going on? Where you been, buddy? It's reality TV, man. Are you looking up segues right now?
How does he know?
We had a whole like Bachelor in Paradise episode over here.
What are you guys talking about?
Man. Wait. Is Annika the sneaky link in math is the original? Whoa. It's math, we just said. No.
What is going on? Is he on a business trip to New Zealand? Wait, what if Josie got rid of James? Oh!
James, are you alive?
Joseph, what you doing?
Yeah, we're recording. That's what this little button is. We want to make sure that James feels included. Yeah, he needs to know what's going on in his absence. Pull down his mask a little bit so you can see how red his face is. All right, let's move on. Okay, it says, what is the perimeter? Are you ready? It says, what is the perimeter of the triangle? So if we want to find the length of the diameter so we can find the perimeter of the triangle, how do we do that? Pythagorean theorem. So what are we going to do?
Sorry.
Okay, so Hannah helped us out. She said that the diameter is the C side, it's the hypotenuse. And so if we're doing the Pythagorean theorem to find the missing side, because this is a right triangle, we would have 12 squared plus 28 squared equals C squared. So we can do the math on that. 12 squared plus 28 squared. I got 928. Is that what you guys got? Okay. And then what'd you guys get for C?
30.463.
30.46 something or other, but it's just around the nearest 10, so.
Okay, so 30.5. Okay, so we're gonna do 30.5 for that side, and they want the perimeter. So perimeter, not just C. So we're gonna do 30.5 plus 12 plus 28. So what's the perimeter? Perfect. Okay. Well, that was kind of a fun problem. We got some trig in there. Yeah, we also had a side tangent, a tangent. Oh, for a reality TV show. All right, let's do 132. So it says Vicky looked at the outside of a circular stadium with binoculars and she saw Joseph and Annika playing footsie. She estimated the angle of her vision to watch them play footsie was reduced to 60 degrees. She was positioned so that the line of sight on either side is tangent to the stadium. So here's her tangent, point tangency, point tangency. What was the measure of the arc of the stadium intercepted by the lines of sight? This is the wrong sight. Let's fix this. Thank an English teacher. Lines of sight. Somebody did that wrong. All right. So the what? No, I looked up a lot of different like reviews that I could find that would possibly, and then I copy pasted like a real person. I almost said mofo while teaching. All right. So what we're trying to solve here, the measure of the arc of the stadium is it's that right there. That's what we're trying to solve for. So let's say, can you guys remember from that unit? Because again, we can't fake this. This is not algebra. This is not an equation. Can you remember, Corey, do you have a question about this? Or are you remembering what we're going to work with? Yeah, so what's the formula that you do with this? Not 2x.
Minus the little and divided by 2.
Yeah, it's so the formula is big arc minus little arc. The formula is big arc minus little arc divided by 2 equals the angle. That's the formula. So if we plug in what we know, we have nothing for the big arc minus little arc divided by 2 equals 60. But right here, we have no label for the big arc. And this is what I was telling you guys about, where in this particular unit, we never did a question like this, but there are multiple questions like this on this review. So we're going to do it once here. And then as you guys are working your way through this review, you'll be like, oh, that's another one like problem 132. And you'll be on another, and then you'll be like, oh, that's like 132 again. And you'll be like, oh, that's like 132 again. They do it multiple times. The geometry units are hard to cheat. You kind of just actually have to do the math. Yeah. Okay, so if this is X, what do we, like if this had been a number, how would we know what the rest of the arc was? Yeah, it would be whatever the rest of the measure was from 360. So if this was 100, the rest of it would be like 360 minus 100 is 260. Or if this had been 50, we would say, oh, the rest of it is 360 minus 50, which is 310. So that's how every time we did it in that unit, they would always, with the arc, they would always have given you one of the measures of the arcs, and then we would find the other measure by being like, oh, it's the rest of the circle, so just do 360 minus that. So for this, we're going to say the little arc is X, the big arc is just 360 minus X. Does that make sense? Okay, so now what we're gonna do is we're still gonna follow the formula. We're gonna say big arc minus little arc divided by 2. So big arc is 360 minus x. Little arc is x. So we have 360 minus x divided by 2 equals the 60-degree angle. Big arc minus little arc divided by 2. Okay, so now we can actually do the problem. What do we do to get rid of this as a fraction? Do you guys remember? Multiply by 2. So that was always the first step, is just get rid of that fraction. So now we have 360 minus x equals 120. And what happens when you combine like terms if you have a minus x and a minus x? Negative 2x. So 360 minus 2x equals 120. And then what should we do? Subtract 360.
You get negative 240. Then divide by negative 2, divide by negative 2. Then you get 120.
Okay.
Positive.
So, okay, and then we look back at the question because we just want to make sure, since we labeled the picture, we want to make sure that the x is in fact the answer based on how we labeled the picture. Okay, so the question said she positioned herself so that she could see Joseph and Annika playing footsie. So it was in her line of sight. And what was the measure of the arc of the stadium that was intercepted by her lines of sight? And the arc of the stadium intercepted by her lines of sight is what we called x. And what we called x is what we solved for. We solved for x. So we got 120. So the answer is 120. Okay. So we did get it. Okay. Does that make sense? Yes.
Yeah.
Okay. So we got that one. Look at 135. They did it again. See it? 136 is the same formula, but they actually gave you numbers for both arcs. So you're right to recognize the formula, but they didn't do the x thing and the 360 minus x thing, but they did do that in 135. Okay. Let's keep looking. I think those are going to be pretty good. Okay, so now let's move on to trigonometry. So we're going to go to 146. So now we're going to get back into some more algebraic type problems. And so we're going to go back into like, okay, give us some strategies with Desmos. So 146 is a graphing one. So this is a Desmos strategy. But if you look, these are in terms where it's like, we want it to be able to graph on Desmos, but we want it to graph on Desmos in terms of pi. Because if you look really close and you have to like really bring it up to your face because the numbers are so small, the x-axis here is in terms of pi. So we want to know how Desmos can do that. So let's go ahead and get on our computers so that we can graph this on Desmos. So we got 3 cos. You just type the word cos, and then x divided by 4. You might have to type that in parentheses. X divided by 4 minus 2. Okay, and then we want this. I was sharing the correct thing. We want to be able to see it so that we can kind of compare this with the version that's on the multiple choice version, and we want to be able to see some of those pies and stuff like that. And so what I'm going to do is I'm going to take this and I'm going to go up here and I'm going to click the wrench. And then for the x-axis where it says step, for the x-axis where it says step, I'm going to type pi because the number pi is not PIE, that's dessert, just pi. And what happened is it just switched it over in terms of pi. So now I can kind of compare it to the way the graph moves. Does that make sense? I can kind of compare it to the way the graph moves. Okay, so and you can kind of switch it to make it, so do you guys see how all of these are between, well, A, B, and D are between -6 pi and +6 pi? Does everyone see that for the X values? So what I can do is I can take this and I can make it from -6 pi to +6 pi so that it's easier to compare to at least those three answers, A, B, and D. And then the y-axis went between -6 and +6. Oh, that's already kind of accurate. Okay, so can you guys tell which answer it looks closest to? It looks closest to A, absolutely. Are we in agreement on that? Looks like A? Okay, so if you want to just make sure that it's definitely not C, because C is the only one where the x-axis doesn't match, then C looks like it's between -pi and +pi. So we can go back and just take this and change between -pi and +pi. And then definitely it is not answer C, because once I changed my left and my right to kind of match C, that clearly is not the same shape. Yes. Yep, sure. So the answer is A. I think that is mostly, should we try another one like that just to make sure we can do it? Or did that make sense? Was one example enough? One example was good. Okay, that's about all the trig ones. The rest of the trig ones you're gonna kind of have to know how to do. And then the statistics questions, as you can imagine, those ones are gonna be like the geometry questions where you're actually gonna have to understand them. You're actually gonna have to use your knowledge of statistics to answer the questions. So at this point, I think I've given you all the calculator strategies I know. You wanted 145? Okay, let's go ahead and go back and let's do 145. Okay. Oh, actually, yeah, this is something I did want to do. So it says 145. This is good because do you guys remember when we did arc length and sector area? Arc length and sector area. So let's get those formulas written down real quick. So arc length, sector area. So we had sector area, we had arc length. Okay. So both of them started out that it was the measure of the arc divided by 360. The measure of the arc divided by 360. And then you had to multiply it by something. Hi. So for the arc length, what's up? Nice. Hey. Nice job, Lucas. It's okay. Don't open it right now. If it spills all over the floor, I'm gonna be mad at you. That's fine.
She's already broken it on it, but teacher, can you make it sure it's Yeah, you're the good as enough to share.
Don't open it right now. Don't open it right now. All right. So the formulas are, remember sector area, the next part has to do with the area of a circle. What's the formula for area of a circle? Pi r squared. And then for arc length, the next part is the perimeter around a circle, which is also known as circumference. And what is that formula? Starts with a 2. No, 2 pi r. Okay. So when we did this unit, are we listening? When we did this unit, we did not know what radians were. We'd never dealt with radians before. So we only learned the degree measure version of this formula. Now, when you look at problem 145, it says, what is the approximate length of the arc? Okay, so it says the approximate length of the arc. So which formula are we going to use? The first one or the second one? Second one. Okay, it's arc length, so we're going to use the second one. And then it says of the angle of 4 pi-thirds radians. So we are not using a degree measure, we're using a radian measure instead. Does that make sense? We're using a radian measure instead of a degree measure. So all we're going to do is you can use the exact same formula, but you use the radian measure instead of 360 degrees. So what is the radian measure equivalent of 360 degrees? It's 2 pi. So what we're going to do is we're going to copy this formula down, but we're going to use a radian measure over 2 pi instead of a degree measure over 360 degrees. But it's the same formula, it works the same way, okay? So, and you can, or the other option you'd have is you could take 4 pi-thirds radians and you could convert it into degrees and then do the problem. You could do it either way, okay? So what we're going to do is we're going to write the arc length formula. So I'm going to say the arc length equals the measure of the arc divided by a full circle, which is going to be 2 pi, because we're going to go ahead and just do it in terms of radians so we can see how that goes, times 2 pi r. I've gotten so many phone calls. Yes. Unit circle? No. No.
What if you memorize it and you draw it in your pack?
Yeah.
You can do that.
Okay. How much time do we have on it?
It is 3 hours regular time, and then you get an extra hour after everyone's done if you want it. All right. It's 60. 10 of them don't count. Yeah. All right. So he was thinking about Skittles. Okay. All right, let's plug the numbers in. So we have an arc that is subtended, whatever that means, by an angle of 4 pi-thirds radians. So where do we put the 4 pi-thirds? Yeah, so this is the angle measurement. So we're going to say the length of the arc equals the measure of the angle, 4 pi-thirds, divided by 2 pi. I know this looks like a mess right now, but it actually cleans up nicer than the degree one. So give it a second. It's going to be a nice answer. Times 2 pi, and then we have the radius. What's the radius? 6. Okay. So when you guys look at this, what do you see as far as like simplifying? What's some simplifying we could do before we plug it in? What more than just the pi's? The 2 pi's. 2 pi. That cancels. Yeah. Yeah, that's the kind of cool thing about doing it in terms of radians is that the 2 pi and 2 pi cancel out. So what we're going to do is we're going to do 4 pi-thirds times 6. And the reason we're actually going to type the pi into our calculator is because the answer choices do not have a pi in them. So that means that these decimals, they must have typed it in. Okay, they must have typed that pi in the calculator to get the decimal. So we're going to do 4 pi-thirds times 6. And what do you guys get? 25.132. And so the answer is C. Marvelous. Okay, so I'm gonna let you guys work. The next 2 days, Wednesday, Thursday, are work days, not goof off days, work days to practice your strategies and to make sure that you know the calculator inside and out, okay? If you finish the unit reviews, then let's go back to this. If you finish the unit reviews, then you're going to be going back to this and you're going to do the mixed reviews. So there are two mixed reviews where it just has the questions all scrambled. So the first mixed review is the 2018 released EOC. So these are actual EOC questions from 2018. So that's the first mixed review. Again, by the time you get there, I will have a place for you to submit your answers. And then after that, you will have another mixed review of similar types of questions, but they're just not in EOC form. It just looks like this, okay? So there are plenty of questions for you to work on for the next 2 days. Nobody should be sitting there twiddling their thumbs, okay? Everybody has enough problems to work at on the computer, okay? So practice. So for the next 2 days, your only job is to work and to ask me questions about how do I use Desmos to do this? How do I use my graphing calculator to do this? Or I forgot how to do this. Where can I look at my notes? What do I need to do? Just questions to follow up on the math. Yes, yes. Yes, yes. Yes. So either the mixed reviews, you either finish this stuff early and you start working on the next 2 days, or those two mixed reviews you're gonna work on between Thursday this week and when you take the final on Wednesday. Because remember, we are gonna have that mandatory study session on Tuesday, which is the day of the Math 1 EOC. Okay? So the plan is that's the day that you guys are going to have your final chance to ask questions, get those turned in. Ella.
2 questions. One, are you going to post answer keys for the next reviews? And also, should we just go home and print them tonight? How about this?
I have copies of those, so you can grab copies of those. Yes. So I will post answer keys for those as well. I will probably put a deadline. I might have the deadline for those be something more like in the afternoon as opposed to midnight so that I can post the answer key and give you guys a chance to work with the answer key before the test the next day. So those might have a deadline that's more like a 5 p.m. sort of thing, so that from 5 p.m. to whatever the next day when you guys have the test, you have a chance to work with the answer key for any issues that you had with those. Yeah. Lucas, did you still have a question? Those are they're about the same length. No, the mixed one of them has 51 questions. The other one has like somewhere around 51. Hold on. Yeah, Ms. Rice had questions. Ms. Rice had lots, 30 questions, 51 questions on the mixed reviews. Okay, but remember, if you have you don't have to do every single one of them by hand. A lot of them are calculator, manipulating on your calculator, and you don't have to show work, okay? Any other questions? Yes. The test is on a computer. So when you come in to take the test, you're gonna be sitting in a room full of desks, sitting with your calculator. On the day of the test, you have to bring your school assigned Chromebook. If you do not, you will be screwed, okay? So if you do not have a school assigned Chromebook, you do not need to bring a computer because they will have one for you. They know who has Chromebooks. So if you have a school assigned Chromebook, you have to bring that Chromebook. If you do not have one, they will have a computer set up for you. So you'll bring your school assigned Chromebook. They will sign into the NC Test like computer app. They will sign into that, and that's how you'll be taking the test. So you'll all be sitting in rows, everybody's sitting on a computer taking it. You cannot use your actual computer unless it's a school assigned Chromebook. Yeah. Any other questions? Okay, cool. So go ahead, get to work on that. Let me know if you have questions. I'm gonna start working on the version that shows work, okay? If you get past the versions that are just the individual unit reviews and you're ready for the mixed reviews, I've already made copies for you. Do not print them on your own. The copies are in piles over there on the edge of the table, Ella, underneath the papers that are ready to hand back. If you go underneath them, yes, that's where the copies are. All righty, you guys are good to work. I will get some music playing for us.